I mentioned before that if you had an F in algebra or in MATLAB, that I would be inviting you to Saturday Academy. Keep in mind also that you could just like do the work that I wrote down on that paper on your own time, in here, in tutoring. I have tutoring on Wednesdays after school, in another teacher's tutoring. I don't know. I just don't know how else to convey that, like, that needs to get done. That's what's bringing your grade down. All right, that prioritize. Others of you might just have a D. I mean, D's like get you diplomas, but you obviously want to shoot for like higher than that, obviously. So I still recommend Saturday Academy to everyone, even if you have an A. Keep in mind next week, we're all testing for Unit 5. So the study guides you can use. I know I have mine published in my algebra. If you have a different algebra teacher, you know, I can share it with you, just ask. But like, I already have the practice constructed response made. And pretty soon I'll have the other practice illuminate test ready, and you can have basically a preview of what your test is gonna look like. So in the beginning of the semester, things tend to affect your grade a lot. Like small quizzes that normally wouldn't affect your grade that much are affecting your grade because that's the only thing that's in there. Next week, 150 assessment points get added to the grade book. So you really need to make that unit test a good one. Are you just observing?
No. This is 22. Where's Miss Adams from?
She's in that side of the hallway.
That's that hallway?
Yeah, it's like a science group on the wall.
Yeah, you're.
I don't know her room number, sorry. No, that's my room number. Oh, 206 is my room number. I don't know her room number. Okay, anyway. Moving on. Big things coming. And what most of us algebra teachers do with the Unit 5 test is if you score higher on that test than you did some of those smaller quizzes, we will match that score. So say you failed both your quizzes and you managed to get an 80% on the Unit 5 test, we will match that. Say you got a 0% on your quizzes and managed to get a 50% on the unit test, we will match it. It will help you some. But still, lots of things you can be doing to improve your grade. Just ask and you need help. Lately, I don't know what it is. Maybe we're just feeling really confident in the material. Lately, people have not really been asking me questions. So I expect to see those 80% or higher, especially if you're not asking questions. Do not spend more than, I'd say, 3 or 4 minutes trying to figure something out yourself. All right, and redirect you where to look. Today's lesson 15 that we did, I don't think was anything new at all. It's just more practice of the things we've been doing. So I don't necessarily feel the need to do any sort of like examples like I normally do. I would just remind you that when we're repeatedly applying a percent increase to a quantity, that you probably want to use this version of our exponential function equations compared to the other one that we've been using in algebra most of the time. This one is better for when it's a percent change. Because the R stands for what? The growth rate as a decimal. Okay, so like if it says it's growing by 18%, then that decimal is 0.18. If it's growing, you add it to the 1. If it's decreasing by that much, you subtract it from the 1. Things we've all done in here, like especially on that math lid before. So in algebra really is nothing new. So even if you haven't had the algebra lesson yet, I'm confident you can still do it. I checked, it was enabled for everyone, but if I missed anyone, let me know. Any questions on anything? And I fully do not mind you having free time once you get your stuff done. But, you know, always look like you're doing something productive, even if it happens to be for another class is fine. But I do update your grades as frequently as I can, but it takes a long time when I have to pull up like your grade book for algebra see if you got 80% or higher, see if you did any of your password, like it takes a while. But I'm noticing some people are not meeting that threshold, and that's why I'm adding to the list of people that need to turn in like their devices. So if the data shows that you can be on your phone and use your headphones and work at the same time, and I'll let you keep using it. But if it's showing that it's not helping you, then I will continue what I've been doing with this collecting that. So questions on that? All right, so this is today's task. So keep in mind, like, get your notes up to date, go back and make sure the others are at 80%, maybe consider picking up the study guide and starting it. But today's task is this.
And we got a request for the entire one, so everyone will benefit from the first part. All right, so one $1,000 loan charges 5% interest at the end of each year, while a second loan charges 8% interest at the end of each year.
Complete the table with the balances for each loan, assume that no payments are made and that the interest applies to the entire loan balance, including any previous interest charges down to the nearest tenth if necessary. So for this, you would have had to make an equation for each one. Let's call it loan A. Oops, I spelled that wrong. And use this as a setup if you struggle also with making the equations. A standing for initial amount. So in the first loan, what's my initial amount? And does interest add or subtract to the total? It adds to it. So it should be the 1 plus the percent as a decimal. What's 5% as a decimal? 0.05. 0.5 would be 50%, so you don't want to do that. So 0.05. X would be however many years. You know, this is all being recorded. My mic is super sensitive. So just, you know, just don't say anything at all. So loan B starts at also $1,000. It is also growing, interest adds to the cost, but their rate is 8%. What's that as a decimal? Okay. So then for this part, when you're filling in the table, you're gonna have to use your calculator. And each time you are just changing the exponent. Does that make sense? So the setup is the hardest part. The rest you use your calculator for. I do need my calculator because I can't do that in my head. Give me a second. Okay. Okay, so if my first loan was 1,000, and in here I'll have it already, well, actually I'll expand it, that's fine. The first exponent for year 1 would be 1, and it's telling me 1050 for that loan. I'll just do all the ones for loan A. Okay, ladies, disperse. I told you too many times already. Okay, so here's the first 3. All I changed was the exponent. And then for this one, it wants to know, like, based on your expression, what would have been in the parentheses. Okay, so it doesn't have the 1 plus the 0.05. So what is equivalent to 1 plus 0.05? So it should be that one. Do the same with the other one, knowing that this is the equation for it.
I'll even let you try that. Like, I won't necessarily do it for you. Try it. I gave you the expression. You do the same. Change the exponent each time and then tell me what should go in here. For the next part of it, it says, which loan balance grows more quickly? So which one do you guys think? The one at 5% or the one at 8%? The higher interest grows quicker. So the loan with 8% interest grows quicker. The graph representing the blank loan will have a higher y coordinate than the graph representing the blank loan. So which one, how will it look on the graph, essentially? Which one will be higher? The 8% loan or the 5% loan? I think it wants it in this order. And we can graph it to compare. So I will pull up my graph. Okay, so you see how this graph doesn't really show me much? It might still be enough to answer the question, but you might need to adjust the settings because we don't really care about the negative x's. We don't care about the time before the loan was taken out. So I'm gonna press the adjust settings right here, graph settings. I'm gonna make the x start at 0. And I don't know how long you want it to go, but we're talking about years, so I'd say like 10 years about. The y-axis could also start at 0, and we're looking for when it reaches 1,000, so maybe I'll put a little bit above that. And it's color-coded. So which one is higher on the y-axis? The blue line, which goes with the 8%, so that further justifies the order. And then let me go back. Yeah. So, and aside from I didn't answer these ones, I'll let you guys figure that one out since I did this one. But that is right. It's marking them all right so far. Other questions? Anything Unit 5 related? Number 2 on today's? Okay. So May and Elena are shopping for back to school clothes. They found a skirt that originally cost $30 on a 15% off sale rack. Today, the store is offering an additional 15% off. To find the new price of the skirt in dollars, May says they need to calculate that way, where it's 30 times 0.85 times 0.85. Elena says they can just multiply 30 by 0.7. So how much will the skirt cost using May's method? So all you really have to do for that part is put this in the calculator. Got it? What was it? Okay, so that's putting what May said to put in. I'll believe you. For Elena's, when you put in 30 times 0.7, you get, okay. So there's that part. Complete the following to explain why the expressions used by May and Elena give different prices for the skirt and then which one is correct. So let's work that out up here. Let's figure out what the answer should be. That'll help us explain. So if it originally cost $30, and I think you will agree after you have the algebra lesson, I think it's easier just to start from our exponential setup, where it has an initial amount. What was our initial amount? And do these discounts add or subtract to the cost? Okay, so then it's going to be 1 minus our rate as a decimal. So what's 15% as a decimal?
And the X will be how many times they applied the 15% off. So here's one time, and then here's another time. So my exponent will be 2. That will give us the correct answer. And I'll put it on my phone calculator, so I don't have to go back and forth. Okay, so May is correct. The expression used by blank takes 15% off the original price and then 15% off the discounted price. That's how it should be. So that would be May who did it right. The expression used by Elena takes 15% off the original price and then an additional 15% off from the original price, which you can't do. You can't just make it 30% off. So May's method is correct. Let's see that the P is right, and it is. All right, other questions? From any unit 5 stuff? So the graph that we just looked at was comparing 2 different things. What would go on the x-axis? The time. Time almost always goes on the x-axis. So that would be my time in years since they took out the loan. What would go on my y-axis? And that would be how much they owe. So what they owe. And that would be in dollars. So keep that in mind. Which axes then would I look at to see my starting balance? The y-axis. And then this is like related to what the y's can be. What did our loan start at? So then I should have that as my starting point, not 0. And since there's only 2 options, it must be that. For the x-axis, the time in years, should we start at 0 or 1? 0, because we always like, whenever x is 0, that's our y-intercept, which is 1,000. So I would go off that. So yeah, you do need to know like domain and range still. Not necessarily formally talked about it again, but you still have to remember it from last semester. Other questions at all?